about the trigonometric functions and how we could apply them within CSS. So first I'm going to make a quick revise about trigonometric functions. We will start by drawing a circle with a radius with 1. Then we will make this arrow rotate around. We will notice that there is a degree shaping here while this arrow is rotating. For example, if the arrow starts from here, the degree 0, then 45, 19, 180, and so forth. As we go there, we could draw the x's, x and y, and we will take each dot here. Each dot will take x and y. If I take this point, for example, and wait the arrow to come here, I'll see that there is a degree here. This degree has, and this point has x and y. So the cosine for the degree shaped here is nothing but the x's for this point, and the sine is nothing but the y's for this point that shape the degree between the main x's here and the arrow. So as we have noticed, when the cosine value is just scanning these values from -1 to 1, and the same for y value, we're scanning the values from -1 to 1. So if we take the degree, we will have various and different cosine values from -1 to 1, and the same for the sines. So if we want to use some x's for some degree, we will take the cosine, and the y's we will take the sine. How we could take the benefits from applying this trigonometric functions to our CSS? I have two real-world examples where we could take the benefit from the cosine and sine in our CSS. I have a small demo here where I have the first one. I have 10 red circles that animated in the same animation delay. There is no delay between each circle. My goal is to take the first circle and multiply it with some number, so I could make it animate with different delay. The same for the second and the third. So what I'm going to do here, I'm going to loop through my circles using Css, and I have 10 circles. For each circle, I'm going to do the following. I'm going to take the degree, which is 360 by 10. For this degree, I'm going to multiply this degree by the count of this circle. I'm going to take the degree and put it as a sign for the animation delay. If I save and refresh my demo, you will start to see how the animation delay for each circle now depends on the sine degree calculated for each circle. If you play around with this, you will have a very beautiful results. For example, if I make this cosine, I could have a wing animation, something fly. You just need to play around and find your things from this. The second real-world case is when I have here 10 blue circles on top of each others, and I want them to be distributed equally. How I could do this? I make a preparation for it. I'm going to go through each of the blue circles, and for each circle, I'm going to take 360 divided by 10. Why we have made this? If I go back to this circle and I want to divide or to distribute 4 elements equally, I'll put the first one here, the second one here, fourth here, and the third here, and the fourth here. If we divide 360 degree by 4, I'll get 90 degree. If I put each circle on x by, for example, 0 by 90, I'll put the first here. 1 by 90, I'll put the second here. 2 by 90 here, and 3 by 90 here, and so on. So if I want to distribute them equally, I need to calculate the degree that if I made them multiplied with their indexes, they will be distributed equally. I take the basic unit, the basic degree, and then multiply it with the index of this circle. Now, what I'm going to do is I'm going to move each circle for x and y. I'll take the first one and move it for x and y for the 0 degree, which will be here. The second one, I'll move it for x and y. As we have mentioned before that the x is a cosine and the y is the sine. So this degree that we have here, make a calculation for it. We will, for each circle, we will make a calculation for translate. We will translate the circle for x's using the cosine and for the y using the sine. If I make a save and refresh, you will notice that we have now 10 circles, 10 elements distributed equally. Thanks for watching. I hope you enjoy my video. Goodbye.